Okay, welcome back. You ready for dinner? No? Not yet? Okay, we have to wait for 7 more hours, right? So, okay, we're gonna have now Karl, who's gonna talk about CICD. Remember, if you have any questions or comments, please use the mics. There's another one over there, so please.
Okay, great. Yeah, so I think also, I'd realize I have 2 hours for this, and I definitely don't have 2 hours worth of slides, so there'll be, so please ask questions, and I'll do some demos, but then there'll be time to sit down and actually work on your code. First of all, how many people actually succeeded in getting some unit tests? Like if you type Pixie run PyTest, do you have at least a green light or something like that? Okay, most, good, because it's useful to have that working before this, but you'll have time to fix it if you haven't. So, okay, let's start. As we just mentioned, I'm going to talk about continuous integration and delivery and explain exactly what that is and why it's interesting. It's also something that I guess a lot of people, if you haven't been working in projects where you share code with lots of people or do big open source things, you might not have actually ever used this, but you might maybe know what it is. But it's always something that for me takes a bit of a effort to set up, but once it's set up, it's very, very useful, and I'll show you why. So previously, you've learned in this school, you've learned how to kind of debug code and write unit tests, as we learned this morning with Max. And now this extends quite a bit from what you from this previous lecture, in that we will take what you did in writing unit tests and also other things like linting. Have you talked about linting yet? I missed the first 2 days here. So. That's next week, so I'll mention it a little bit, but that's something that, linting just means, I even put it down here. Is there a pointer here? Yeah. It just means checking code quality. It literally means finding, removing bits of lint from your clothes, and making it look presentable. So it's like checking that your code doesn't have, ugly indentation or is missing a doc string and things like that. But that's the sort of thing you can automate. But more than that, it's not just being able to automate running these unit tests, it's also automating checking that your code works in different environments or with different dependencies, for instance, new versions of the dependencies you use. And then finally, we'll talk about maybe to a little bit lesser extent, how to automatically do things like package your code or results and to share them. So this is all about automation, essentially, of the things you've learned in the past. And this whole technology is called CICD, so continuous integration, continuous delivery. And it's not just a technology, it's also a sort of development philosophy also. So this, I'll show you a little bit about why that is towards the end, but the idea is that it's not just talking about how you automate things, but that the way you write code and the way you share code with other people follows this sort of infinity symbol figure 8 thing here. So you write your code, but then always, this is not a totally continuous thing, but in every time you, let's say, make a commit or a change of the code, it gets built, the tests get run, and then occasionally when you're happy with the state of your code, you make a release, in which when you make a release, that's not just marking that your code is ready, but it also maybe creates a package and deploys that package somewhere, maybe to the Python package archive if it's Python, or to some server somewhere that's storing where it is. It could even be to something like Zenodo, which you might know is where you can put software and papers and things and have a DOI, an ID, a fixed ID assigned to it for citing and papers and things like that. What we're talking about here mostly is scientific code, I guess, is what most people are interested in, but in some cases you have code that is not just running an analysis, but actually, I don't know, launching a website or something that's continuously running, it's a database or something like that, and so after deployment, you can have this all automatically start operating and being monitored, and then you use that to plan your next release. And I think the big core philosophy of using CI/CD kind of methodology is that your code is always in a known state, and that state should be that it runs and tests pass. And when I say code, that means, let's say you pick your master branch or your main branch. The main branch of your code should always be working. You might be developing some other branches and they're broken at the time, but you can always rely that there's one version that's always working. And this is something that I think if you develop code on your own, and if you sort of learned how to, and I've done this many, many years in the past, that I work on stuff, I get go to another project, come back to it, a few weeks later or months later, and it's completely broken. I have no idea where I stopped. I forgot what I was debugging. The code doesn't work anymore, or it worked yesterday, and I want to now use it for something really quickly, and it doesn't work. I'm in a state. So it's really useful to keep your code in a working state, especially over a large amount of time. And by the way, this doesn't work just for code. I also use this quite a bit for documents. So if you write documents in LaTeX, and sometimes you come back a year later and want to rebuild the document, and you type LaTeX make or PDF LaTeX or whatever, and it just doesn't work, and there's all kinds of dependency problems. You can solve that by following these principles. So we'll see how that works. So it's nice. I think it's a nice way to work. It takes a bit of effort to set up, but the philosophy is quite useful. So first, let's talk about just the CI part of this. This is the continuous integration. And one thing we mentioned, I think, last time in the last talk, there was a list of different types of tests. So what you've implemented so far are unit tests, and there's also integration tests. And I think that the line between the two is very blurry. What do you call unit tests? What do you call it integration tests? It depends a bit on how much you're testing. Like you could say that calling a very high level function could be an integration test because it's calling all your lower level functions, but it's also testing that high level function, so it's in a way a unit test. So, but generally, what I think of as integration tests are, running your analysis is sort of, in a very minimal way. It would be you're really doing everything that it's supposed to do is an integration test, but also checking, if you have external libraries or external services you have to connect to, that's what you're also want to check that you're integrating with those services and that hasn't broken yet. For most scientific software, you're not usually making many API calls or, JSON, REST, APIs and like this with other things. You're just writing some scientific code that does things in order. So in a way, it's more checking that the dependencies of your project are up to date and that they don't break when there's a new release of one of them. So let's first of all talk about this continuous integration. So what this means is basically how to automate software code quality and unit testing using GitHub is what we're going to be showing here. And I'll mention in a moment that there's lots of different ways to do this. So first of all, what exactly is this part? What is CI? So it's the practice of constantly or frequently taking anytime your code changes and integrating them into a shared main branch assuming that they meet certain criteria, like that their tests pass. And each time you make an integration, or each time you open, let's say, a pull request, did you guys talk about pull requests and things like in the previous? Yeah, so this is all understood. That just opening a pull request automatically can trigger an automatic process that verifies the code is in a healthy and working state. And that's nice because if one lets you catch bugs early, it reduces human error, and also I think this is the main thing, it reduces burden, and it makes working with lots of other people much happier because you're not fighting with each other, constantly breaking different parts of the code and blaming who's doing it. You know exactly what you want, and that's something that I think maybe we didn't mention or wasn't really talked about in the last talk so much. But unit tests are not just testing that the code works, but you can also use them to enforce that other people use the code in the way that you want them to. So that if somebody else, like you write a nice function, it works the way you think it does, but then another developer comes along and wants to change it, they think of a quick way to improve it, but they change maybe which options it takes, and that wasn't something you expected, and that will break your workflow somewhere else. Well, the way you do that is you can write a unit test that enforces that your function works the way you want it to, not just that it gives the right scientific results. And having this done automatically means that other people are forced to react to that you broke, so that the code broke, the code that they're changing broke your expectation. So what does it actually mean in practice? Like what is it all? It's nothing really complicated. Basically, it means that you use an external service of some kind that runs things like code linting utilities. Again, this just checks that your code looks nice or follows best practices. It will then download, build, and install your code in a clean, repeatable environment. That's also important. And also one of the reasons, using Pixie makes this a lot easier, by the way. This is something that before tools like that, which can manage environments that are in a repeatable way, it was a bit harder to ensure that. Then it runs all unit tests usually to ensure that the code works, or at least up to the level of what you've defined in the tests. It can run larger integration tests that connects things together if those are available. And it optionally will keep track of things like changes to test coverage. This is something I'm not going to cover this much, but this can be done as well. But every time you run one of these repeatable workflows, you can send the results of the test coverage to another service that will then keep a timeline and show that, okay, as over time you've gotten better coverage, or like the previous commit reduced the coverage. You added lots of code and didn't cover it. And then you can also emit a warning or something when that happens. You can also report on other failures and problems. So imagine some of your unit tests you connect to an external server to download some data in your test. And once in a while, once every few months, the server goes down. You didn't anticipate that, and your code fails because of that. This can be used to ensure that to uncover that kind of problem, because you can also have these tests run not just on pushes, but let's say periodically, like once a day or something if you want, to ensure that things always work. And you can also use this to generate artifacts, which means this is the deployment part, and we'll get to that later on, but that like packages or documentation or results, and we'll try that. And so you might ask the question like, okay, but I can just do this on my laptop. I type, pixie run test, pixie run check, or whatever you've done in here, and it's fine. And you should do that, and that's great. But that doesn't cover everything, right? So, one, do you really remember to run that every time? Like, so every time you push you make a commit, did you really sit there and run all the tests? I don't. I always forget it, or I'm working fast, so I don't do it. So I often will commit a change that actually didn't pass the test, just I forgot to run the tests. Sometimes the tests you've developed so far are probably pretty quick. They run in a few seconds, but like I think Max showed, that tests on code that's slow can be long. They can take a few seconds. Sometimes they can take minutes. Code that I work on sometimes takes like 15 minutes or something like that to run all the tests. I'm not going to sit there running that on my laptop every time. It would drive me crazy. So it's good to have something to automate that. And so I generally this happens to me all the time. I forget to run the tests, and I'm like, oh, everything works, merge, and then I find out, actually, no, it didn't work. But I would never have known that if I didn't have something automatic. But also, I think when you're running local tests, you're probably not also installing new versions of your dependencies and new versions of Python. These things are really tedious, and it's not something you want to do by hand all the time. And that certainly most people don't do that. Also, do you check that your code works on different machines and different OSs? Also, probably not, because you have one laptop in front of you. You're not sitting in front of 6 different OSs or virtual machines or whatever. That would be a pain. And what we mean there is that on different machines or different OSs, you can have different, even just file name conventions. So in your code, you might have assumed that the path is something backslash something, or it's something / something else. And in Windows, it's something / something else. Things can break very easily just switching OSs. The location of temporary directories, if you don't use one of this tempter or temp path fixture that was shown in the last lecture, which automatically sets it. But if you were to try to do that yourself, you would get it wrong, and it would break in Windows. It would work on, let's say Linux, but then maybe Mac OS, it wouldn't work because it's in a different place. But there's even other things that can break, like, okay, this is less of a problem recently, like CPU byte order, but this is something that happened to me during my PhD, is I was working with hardware that used big endian byte order, and which just means that the way data is stored is kind of flipped compared to how it's stored on most computers. And the code, you have to really in the code check that, and I didn't think about it in the beginning. And so this also can check for things like that if you put this into your, if you test on machines that are different than your working environment, then it helps. And then the other thing is, do you work with other developers who might not, even if you say, okay, I always run the tests, I always do everything, but can you guarantee that your coworkers do? And no, of course not, right? Because so you want to be able to enforce that these things happen. So what is a continuous integration service? Usually it requires some dedicated hardware because it's basically running your tests, but usually on many different, let's say virtual machines or even real physical machines. And if there's a lot of people working on a project, this can happen really frequently. These can be running in parallel. So there, maybe 20 people committing to different branches, and then that means there's 20 tests running simultaneously, maybe more than that. Often you need some data, that you want to cache somewhere, and dependencies that you want to install and things. So you kind of need it's nice to have a place to put all this stuff and that it's managed for you. And then, of course, you need sufficient CPU power to run all the tests frequently. And often these are shared between not just your project, but thousands of other projects. So yeah, generally these are big server racks somewhere. But basically, it's you, as a developer, you communicate with some sort of CI service. There's a GitHub provides one, GitLab provides one. They'll show you Jenkins is another one. There's a bunch of others. Those things then talk to runners. That's the terminology. A runner is just a machine that runs the tests for you. But each runner has a different environment, lots of different CPUs, different types of storage, different VMs, containers, et cetera, right? So some of the common ones out there are these are three ones that I've seen quite often. So GitHub Actions is the one actually we're going to use today. This actually integrates really well with GitHub itself, so that's why we're using it. It's very simple to use. But you don't have to use a continuous integration system that's built into the Git hosting environment that you have. It just makes things easier sometimes. GitLab CI, if you're using GitLab, this is probably the easiest one to use because it integrates directly. It's very easy to use. And there's an open source one called Jenkins, which is used by a lot of people. This one you have to run yourself, so you have to have somebody set up a server for it and run it. Often this is provided by institutes and other things. So it runs locally, whereas these runs run the cloud. GitLab actually technically can run also locally. It's a bit harder to set up, but and in this case, you provide both the host and the runners. For the ones that are cloud services, they provide you, which is very nice, usually machines like GitHub provides you Linux machines, Windows machines, and macOS machines for free, which is very, very nice, right? Because that means that you don't have to go buy a macOS machine, stick it in your office to test on macOS, right? If you don't have one, you've got it for free. The other ones you have to pay for that. So I just checked, that might be a little bit off here, but I checked that I think right now Windows and macOS you have to pay for on the hosted GitLab CI. For architectures also, I think you get most of these x86 and ARM, but GPUs usually cost extra. So you have to pay if you want to test on GPU machines, or you have to run your own, right? Run your own runner. And again, with Jenkins, you have to provide everything. So it just depends what you have locally for services. But these are mostly kind of vaguely open source. Some of them are partially closed, but you can kind of run some of these things yourself. You can even, on I think both GitHub Actions and GitLab, certainly GitLab CI, and I'm pretty sure GitHub Actions, you can, if you say, okay, they didn't provide me the thing I need, but I have a cluster of GPUs, you can actually just link it to this, and it'll run on your cluster. It'll just trigger a workflow there. So that allows you to get it. They don't provide it for free, but you can connect it for free to something that you already own, and that's nice. Yeah, and so these are provided by companies. It's actually kind of amazing. This is something that even a few years ago, I think it was just before, when GitHub first introduced their CI stuff, it was all paid, I believe. And I think it was only after Microsoft bought them that they made it mostly free or partially free, or around the same time. So it's only in the last few years that really you get this stuff kind of for free. It's just, and it's a lot of infrastructure behind it, and it's kind of impressive. There's a lot of others out there, though. There's just Circle CI, Travis CI, Azure Pipelines, Atlassian Bamboo, Bitbucket. There's many, many other services that do this. And like I said, you can roll your own if you have the means to do that. But what does it actually? What does this actually do? So all it is you're running your tests and other jobs in a workflow of some kind. And in GitLab, you define this as a YAML file. Everyone know what YAML is? It's a simple text format. Anyway, you probably don't need to know it if you don't, just by looking at examples, it's not too hard. It's just a text format. And all you have to do basically to create a CI workflow is to add a YAML file in a particular format to your repository in .github/workflows/something.yaml. And they only have, there's a bunch of configuration options inside them, but you almost have to do nothing other than these two. You say on, which is when to run this workflow. So, and this can be it's actually a list, so you can have multiple if you want. but let's say you want it just to be on push. So that means every time you've made n commits locally, and you say git push, git push origin or git whatever, or just git push, and it goes to GitHub, it'll start running the jobs instantly. That's kind of what we recommend for right now. That's most of the time that's what you want. But there's other options here. You can also say when a pull request is open, run a particular workflow, or when you can restrict it to just particular branches. You can say on release. So when you make a code release, I don't think that's something we've talked about yet, but maybe later on that you can say when we make an official release of the code, it automatically triggers a particular set of jobs. And then the second part of the workflow are the jobs, right? So what is it what you want to run? And those are just sections in this file. So in this case, I'm going to show you how to write 2 jobs, one for checking your code and one for running unit tests. Generally, jobs run in parallel unless you give some dependencies. I'll show that later on, but generally these things just get executed at the same time. The other thing that you have to, that I didn't show here yet, that you define is the environment in which this runs. So I don't show it here in this example, but you have to put for each job, sorry, I think that you have to show this in a second. You put a section called runs on, which tells you what machine, I say machine to use. It's actually technically, I think it's a Docker container in GitLab or some sort of container. And there's a list of names that you can use that they allow. And that's where you choose, okay, I want macOS ARM 64, I want Linux with, I don't know, 32-bit Linux or something like that, and it'll start up an environment with that. What's important to know is that each time you run this, a new clean environment is started for each job. So it's like as if you had a blank computer. So you start really from scratch. It's like, I mean, I think the base images that they provide have most basic utilities installed, like Git and other things like that. But if you're missing something, imagine this is your runs on machine is just a Linux box. And let's say your tests need some piece of software like LaTeX or something like that, let's say. And you'd have to say, apt-get install LaTeX in your job description, because otherwise it won't be there, right? So it really creates a new blank environment each time. You have to set everything up you need and then run your code. So it sounds more complicated than it is, but then for each job, you give a list of, so you have this runs on, tells you which type of machine it runs on. They give you some nice virtual names, like Ubuntu latest will get the latest version of Ubuntu, but you can also specify a specific version of Ubuntu if you want it. If you want to run on, I don't know, Arch Linux, something like that, I think they have containers for that as well. And then you give it the steps, and the steps are just what to do. And those can be one of 2 things. They can be run, which is just a command line. So just as if you're typing it at the OS's shell, you give it what you want to type. And then you have another option called uses, which is a pre-written set of commands, which might be, inside might be lots of runs, maybe there's other things that uses. These are things that are provided by GitHub or other users. And generally, it's best to look for a pre-written block first, because obviously you can write all the things you want to do yourself, but if somebody's done it and thought about it better than you, it's nicer just to use their work. So I'll show you how that works in a second. So here's a very, very simple example. So here's your, and we're going to actually, in a moment, I'll actually do this. So we'll sit down and actually create this ourselves. So don't worry about looking at the details. But here, I create my very simple workflow. I set a name for it. This is just for, it gives a title. You'll see it appear somewhere. So it's nice to give it something that explains what the workflow is doing. And then I say I want this to run on push. And here are the jobs. And here I'm putting one job that does nothing really right now. I call it unit. Actually, you might want to call this, like, for now, say hello or something like that, because this can be any name you want it to be. I want it to run the latest version of Ubuntu. And the steps here are just going to run. I have 4 steps. Each one is a run. So just type this at the command line, essentially. And here I'm just echoing some information. I echo running tests on, and then they give you some variables that you can fill in. There's a list of these in the documentation. But some of these are like runner.os, github.repository, github.ref, and so you can use these to get information about the environment and your code that you're running in. So this will give you back, like, repo will be your user ID /pcoffee. The branch will be, if you've created a branch name, it'll be the name of the branch. And then you can also do things like install software. That's why I said, so on Ubuntu, if you know Linux, this is how you install a new piece of software. So I typed apt-get update and apt-get install plant UML. Let's say I need that, which is a program to generate diagrams. This is something I use quite often. But it's not installed by default, so I have to actually install it if I want to use that later on. The good thing is if we're using Pixie, you don't ever really need this step, which is nice, because Pixie already maintains all the installation of software. So you almost, I can't think of any reason why you'd ever need to do this if you're using Pixie in your package. You would just, the fact that your Pixie file has the dependency in it will just get installed. And most things that you would install by apt-get are somewhere in the list of conda packages that Pixie can install. Yeah, oh yeah, go ahead. Yeah, stop me at any time, by the way. This is.
And if you are creating on your local machine, could you refer to this local machine instead of runs on Ubuntu latest? Because you can imagine that you have already some machine available, and you can use them as a.
That's where you can. So I have to actually. I know how to do this in GitLab, but I know it's possible at GitHub. But yeah. You employ basically. You have to specify the runner where it runs, and you have to deploy a runner on your machine that GitHub can talk to. So as you open to the internet, it has to be able to communicate with your runner. So it's because really you're telling GitHub. GitHub then has to talk to the runner machine. So it means your machine. Or does it go the other way? Oh, okay. So it doesn't need.
By design, you can run the runner in your private infrastructure. It just talks to GitHub apps if there's anything to do.
But it needs to be able to talk out. Yeah, exactly.
It's
communicating
that
with.
should be true effectively for GitHub, but in GitLab you can also create a local runner, I guess.
Yes,
so
exactly.
In that
case, GitHub as well, I think. See, that's the idea. You have to create a local runner, and then you'd specify that here. Exactly. And then it would run locally. I mean, I rarely do that because running locally, I can just type Pixie run test or whatever. But there probably are some reasons why you might want to run a local one, though, especially if you have a strange piece of hardware that you want. You're testing on some embedded, system running, QNX on a rack mount server somewhere. Then yes, you'd want to have a local runner because that GitLab certainly won't provide you that, right? So you can. Yeah, so this doesn't have to be a container that GitLab supports. It can be a local machine. So I guess this is something I haven't tried on GitHub, but I know GitLab, you just download a program called GitLab Runner. I think it's the same for GitHub. And you just run it, you just execute it, and it just starts communicating, and you don't have to do anything after that. So it's quite simple. But that means also if it's on your laptop, for instance, and you turn your laptop off, suddenly it stops working because the machine needs to be running all the time, right? But it's always possible. So predefined blocks you can get. So there's ones github.com/actions is the ones that GitHub provides, and there's this marketplace which has hundreds of them. And actually, let's look at that just for a second. Does this open? Let me open it. Yeah, let me make this maybe a bit wider. I'll go back to the code later on. But see here, this is GitHub Marketplace, and if you go to Actions, you can even get like a whole list of categories, and you can say like, I don't know, publishing, and it gives you the one. So a lot of these though are very specific. So it's kind of good to just look at examples of what other people use. They are sorted by popularity, which I guess is probably a good way to find the ones that most people use. But the ones we're going to use, actually, so if you look under Actions here and type, for instance, Pixie, because we know we're using Pixie, you find there's one called Setup Pixie. And if you click it, you should see some documentation, and you can see that it uses this use this option, and you have to give it exactly this. By the way, each of these, you always give a version number. And if they update it, you can change that to the newer one, but the idea is you want to keep it really fixed to some version so you don't break. You don't want your test to break because your test setup broke. You want to separate those things as much as possible. There's even a way you can install a bot in GitHub as like an add-on that will check that there's not a new version. It'll look through your CI setup and check that you're not using anything that's been updated. And it'll warn you and say, hey, you should update this, or automatically will update it even. And then some of these pre-built scripts have options. And then so if there's options, you have this with underneath and you give it the options. So the options depend on whoever designed this thing. So in this case, you can specify the Pixie version. By the way, the 63 just came out yesterday, I think. So you could try 0.63. And then there's other options like whether you want it to cache, I guess this is caching the packages that download so that every time you run it doesn't download all the packages every time. Could be good, could be bad, I don't know either way. And then you can go, okay, these are tokens for, I guess if you're using some, not actually sure what those are necessary for, but yeah, so there's always options. Generally, you don't have to specify any of the options if you don't want, if the defaults are okay. And yeah, they give you all the explanation here of how that's worked. So yeah, we'll use that one. The other one that we might use, let me get back to my presentation here, I guess. Nope, there we go, no. This is something you won't use today, but maybe, I guess on Tuesday, when you talk about documentation, you might use the deploy pages one, because that allows you to take documentation that you've built and put it onto a hosted web server on GitHub Pages, which is nice to be able to do. GitHub provides you a web server, basically, that you can use. So that's a useful place. So let's add an action to this. So this first part didn't do anything. It just ran some echo statements, maybe installed some software. But then you can just use this action. So I can say uses actions. The other one we're going to use definitely is actions checkout. So this is very important. This gets your code. So right now you have a blank machine with nothing on it. This actions checkout downloads your code. It does git checkout. That's all it is. I mean, you could run that yourself. You could type install git and git checkout, but that's all up for you and fixes a lot of edge cases and things. So it's best to use the built-in one. So you just put always uses actions checkout. There's no option. There are options, but if you don't give any options, it just checks out your code in the current branch that you're working on. Then I'm going to use the second one, prefix dev, the same thing, set up Pixie. And I'm saying, oh, let's try Pixie version 0.63. And this now sets up everything now sets up an entire environment. Nothing's happened yet. This is just setting up the environment. Then you need to do the stuff. So let's do a demo of actually how this works. I'm curious to see if this actually doesn't cause, actually works doing it live demo, because this is something that tends to go wrong quite often, but you'll see how this can be both maddening to set up because of you constantly, doing whack-a-mole to fix typos and problems. But then once it's working, it's very nice. So if you haven't, you don't have to do this now. You can just watch for now, but you can come back to the slide if you needed to. If you have code that's already working, like I said, that has a unit test or so, create a new branch for this because you're going to start modifying things, or you can still keep working on your current work branch. Doesn't matter as long as it's not the main branch. I guess you've all cloned the repository to your own, like the pcoffee repository to your own GitHub account. Is that right? Okay, good, because that's the other thing is that you have to have administrative access to the repository at GitHub to set all the stuff up, and that only works if it's inside your account, or if you're part of the team that administers the thing. So you could, if you haven't, you can download the solution, add some PyTests, but I guess you've already done that. Okay, so let's try doing a demo here. If I can find where I put my, okay, so what I have here is I've checked out pcoffee. I have everything set up. I can run the tests. Let's run PyTest here, and it works. So I think I downloaded the tests that Vincent had created earlier. So okay, my tests run. So that's step one, make sure things work locally. And what we're going to try to do, let me just open a terminal here, our test suite is basically Pixie run PyTest, right? So that's what we want to try using. The other thing I mentioned, you can do code checking. You'll learn about this tomorrow, but there's tools like, actually I don't know if I have it on here, Pixie run rough check. By the way, is this big enough to see? Should I make it larger, or is it visible? Okay, I can increase this font size if you need. Oh yeah, so okay, I guess I do have rough installed in this environment. So okay, that's something we could try. That would tell you if you had any problems with code quality. But that'll be covered later on. So what exactly that means, but it would basically like running a unit test that it gives you an error if something is wrong. Like let's say you imported a module, then you never used that module. It'll say you imported but didn't use it. It'll complain. So it just forces you to have good-looking code. So then let's actually create a workflow here. So open my notes here for a second so I don't forget to do something. Yeah. So let's first create a simple workflow. We're going to put it in. So this is pcoffee. Remember, it has to be in .github/workflows. That's the only thing that's required, and then you just name it something. Let's call it test.yaml. It says not there, create it, yep. Okay, so now I have a blank YAML file. It's not terribly exciting. First, let's give it a name. So let's test run colon, let's say run unit tests. Or no, it's more than that, because we're gonna do a few things. Let's say test and or check our that code works, something like that. This is just going to appear in the, you'll see in the UI later on. The name doesn't really matter. We want to do this on, and again, you give it a list here. You can either give it a bracketed list like push, or you can write in YAML, you could also write that as push like that, but let's make it small. I should actually write good YAML here, okay. Should actually, does this pop up documentation? I'm not sure. Yeah, so the name of the GitHub event that triggers this workflow, so push. Then what we want is to put the jobs, right? That's just here. We're going to have, let's do a really simple one first. Let's have a job called say hello, right? And that's basically what I showed before. I have, underneath that I need runs on, and I'm going to again use Ubuntu latest, just because that's what I'm familiar with. And then we need steps. And here, let's just do kind of what I did before. Let's, yeah, let's do just do really something simple. We'll say echo, and actually I need to go back because now I don't remember what I typed over here. Where's my presentation? It's hard to have, normally I'd have several windows open, be looking at everything, but on a presentation here, it's a bit harder. Where's my, okay, now I don't have a, there it is. Go here, okay, here's mine. So what did I say? Why is this going so slow? So okay, so let's do exactly this. We said echo running tests on runner.os. That one looks pretty useful. So let's say, and then so these variables look like double $, double curly brace, and then some variable. Like I said, the list of variables is in the documentation, and that's it. So look at that. That's all. That's our steps now. That's it. Say hello. Anything else? Yeah, looks fine. So now we save this. So how does this actually work then? Well, right now nothing happens. So let me also say that in my terminal here, I already did git switch -c to create a branch, and I called it add CI. So I created a branch already here, right? So I'm going to push that branch to my master. I'm not going to overwrite the master branch for that. We definitely want that because it'll make this easier. So I'm in a new branch here, but now I need to, of course, commit that change. If I look at git status, you can see that I've changed. I added some tests here. That's something I'm not going to commit those yet. So far, this doesn't need any of the tests. So the only thing I've done is added this new file. So we need to make sure we git add .github workflows test.yml, right? And then we can do git commit, and we'll just say added workflow. Oops, I'm in where am I? Oh, yeah, okay, this is probably not the best thing to do. So I'm now in a Emacs inside Emacs. This is never a good idea thing to do. Okay, I'm gonna use that. I'm gonna do it this way. I'm gonna add the file. Actually, I shouldn't stage these ones. I'm gonna unstage some of these, sorry. So I don't need the tests yet. That was for something I was working on earlier. Okay, so here's the new file that we just added, and I've staged it. I'm gonna commit it. Let's say added new, or added first test workflow. Okay, and now I'm going to push that to origin, because that's my local copy. And then let's go here to so here's my fork. I'm not sure that's large enough, right? You can read that. So you'll see automatically GitHub, I guess you've learned how to do pull requests and things. Automatically it's detected, hey, I pushed something. Do you want to make a pull request? I'll say, yeah, sure. I'll make a pull request. So I'll just create that pull request from, this is going to be my branch where I add the CI information. And you'll see something different happened than before. You get, well, let's see, actually, it should have worked. Let's see. Checks. So files changed. Why does it say 20 files changed? Oh, maybe I didn't, maybe I committed too many things here. Hold on. This is why I say live coding is never good. Anyway, here's my correct thing. Anyway, this should work. I must have accidentally committed things earlier, but it's not a blank version of my repo, but you'll have the same issues. You've made a lot of changes recently. But this is the file that I wanted to commit right here. And this should now automatically trigger a workflow, and it's not doing it. And this is why I'm confused. This worked yesterday when I tried this. Let me just check. Oh, wait a minute. Am I in the right? Yeah, I'm in the right pull request. This is my. Wait a minute. I pushed it to the wrong place. I think that's why. Is that right? Yeah, sorry. I'm in the wrong. I'm not in my p coffee. This is why. So sorry about that. Let me. Where am I right now? So let's put this. That's why there's all these changes, because this is not the repo. Let's go. Where's my git remotes? -v. Origin is where I want to push it. That's where I pushed it. Okay, so then I need to go to my version of pcoffee, which is in, I'll just put it in my account. Where am I? What's annoying about having the GitHub window small, it seems to drop all of the UI elements that I'm used to seeing. Here we are. They're just hiding them. Okay, so here I can go back to my repositories. And I should see that. Yeah, so make sure you push it to the right place. So here's my pcoffee. Okay, here's my pull request. And why is it not there? Where's my branch? Hold on. Now I'm confused. Okay, hold on. Git push origin. Where did it go? Max, you see what I'm doing wrong here? This worked. I mean, I just did this morning. It worked fine. Origin is there. Yeah. And where's the branch? Oh, no, it's there. Okay, maybe I just didn't reload. Hold on. There. That was when I tried to. Okay, this is my one I made yesterday. That's very strange. Yeah, new pull request.
Then compare
yeah, this one compared to. Oh yeah, there's. Yeah, usually it's automatically. Oh, I know why, because it triggered it in. I know why, because I clicked yes and it triggered it in the main pull request. Yeah, the base should be mine. Yeah, because I don't want to commit. I'll remove that pull request in the main way. Yeah, sorry, this is a bit annoying. Normally that would be the correct thing to do, is to push the pull request to the main, to the origin. But here I want to do it in my own copy because I don't want to interfere with anyone yet. So that's not a big issue. Now I'm creating another pull request here that just in my repo, and now this shouldn't show weird changes, right? Yeah, this should show. No, it still shows. Let me check something here. Let me do this correctly again. Let's oh, there. I'm going to do git switch main. Git reset, sorry, okay, git switch main. Then I'm going to go git switch. I'm going to create a new one here. Add CI workflow, I'll call it. And I want that to be on origin, off origin main. Oh no, I want it to be, this is why, because I'm working on the, no, I know why this is why. Sorry, this is because I have things set up for, I think this is actually okay. I have, because we have these branches for the solutions, I branched it off the solution, not off the main. So never mind. So, okay, let's continue with this. So this should still work. But now the question is, okay, this is actually good. So now it's actually working. So ignore me changing things here. Let me go back, switch back to the add CI. Okay, now we're back here. So what you see now in this new pull request is something different. These things appeared. Sorry, I'm very confused here. No, I'm getting unit tests I didn't write here. Did I? There's only one test YAML file. So what was the day 2 solution? Okay, git branch dash git switch. You can see this is not always easy to do. Add new CI. So now I've got a new one. Okay, I'm just make sure I'm on the right place. Git push, and I'm going to add this. I don't have any tests. Do I have? I know why. This is why. Yeah, sorry. Day 1 solution. This is why I had that test type the wrong one. Yeah. Sorry, I was ahead of myself. That's why all the changes were there, because I have tomorrow's solution there. I'm off by 1. All right. Okay, so now I have a branch off the day 1 solution, which is not what I did before, apparently. Okay, now we should be able to add our test.yaml. Let's see if I still have it open then. No. Okay, so we're going to do GitHub workflows test.yaml. Create that. I'm just going to cut and paste the one from before so I don't have to retype this all again, which was in my presentation. So you can just cut and paste this from the presentation. Just be careful, again, as Max said, cutting and pasting things from a presentation. Sometimes you get indentation wrong. Oh, this looks actually okay. So this is what I had there. I'm going to get rid of this installing plant YAML because I don't need that. Okay, so here's our test workflow again. And I'm going to stage that test file, committed workflow, and then I'm going to push that to, make sure this is right, origin. Yes, and then when we create the pull request here, I want to make sure I branch do it off the right thing. And I believe what I want to do here is just, you don't have to do this the way I'm doing it, but I want to set the base to be coffee. I'm actually going to base it on day 1 solution because, oops. Right, base. Where am I? Why can't I switch back to the previous base? Okay. Now I want to base it off the S3 School P coffees day 1 solution. And I'm going to add this CI workflow, add new CI2, right? That's the one. Okay. Great. Let's just see. Okay, that looks right. Then we have 1 commit. Everything's make sure you have your branches correct when you do this. Okay, here we are. So now this looks like not much. You have, just like before, you've created a pull request. You could merge it right now. Nothing's different. However, you notice there's this checks box, which is now not showing up. I'm very confused why this is not one. Let's see. Oh, because it's set me back to. Now this is the problem now. I'm now in the S3 school, not my version now. This is why. Okay, let me go back to my. Yeah, I ran through this yesterday and everything worked completely fine, but then I created a new. But you can see this is not always easy to set up in first. It shouldn't be this hard. It's just because we have so many branches going on, and now there's in 2 repos in the split. I'm clicking the wrong thing each time. Let's go back to my repository. But that branch should still be there. Well, let's look. Are the actions running for it? Let's check. Yeah. So, okay, it did run. So in my branch now, there's this one that ran called added CI workflow, and it ran this job I just defined, unit tests. And if you look at what it actually ran was, it ran a bunch of these steps. So here's, I echoed the repo name, I echoed the branch it's on, and that's it. So all it's doing is just doing basically nothing now. It's just echoing a bunch of things, which is all I told it to do, which is good, right? So that's fine. So now let's add a step to actually run a test or something like that. So here we need to do uses. So first we want to get the code. And to get the code, we want to use this actions. I don't remember which one it was. It's actions checkout v6. It's called actions. So checkout at v6. That should be a colon, not a semicolon. So that's the next step. Then there, I told you there's nothing else you need to do there. You can, by the way, assign a name to these if you want. If you put name or code and uses like that, it has to be inside. It's like two options of the same bullet point. It's a bit confusing in YAML, but that's a way you can set a nice name. And that name will appear here, by the way. So otherwise, it just tells you the command. So it would say actions checkout v6, but here it's not going to say check out the code. So it lets you make your unit test running a little bit friendlier. By the way, we didn't actually look here when you set up the job. You can see it gives a bunch of output here. You can expand, and you see we're running on Ubuntu 24 long-term service, so you can check what you're actually using and to set up the job. So that checked out the code, but it still does nothing, right? So now let's do another step. Let's call it run the tests, and here, let's first install Pixie because we forgot we need that to run the tests, right? So uses, now we have to use this actions prefix dev, it's called, / setup Pixie, and this was version 0.9.3. And there I need to give it some options. I can have it with, tab in again, and I have Pixie version and 0. Let's try 6.3.0. That's new, as I said as of today. Let's see if it works. And that's still not going to do anything. Now we've installed everything we need, but we need another step which actually runs the tests. So let's call this run the tests, and then that's going to be a run step, and you want to just run Pixie run PyTest. Let's put a -v in there to make it verbose. That's basically it, right? So this should now check out the code, install Pixie, and run the tests. And remember, like every time this runs, it's a completely new environment. So I'm going to now git commit that. I'm going to stage it, commit. So now I added real tests. And then I'm going to push that again to my branch. And now if I go back to my actions here, you should see in a second, another job has started up here, added real tests. And you can click it, and you can see it shows it's running. So again, this will show every job we have. We only have one job, which is called unit tests. But the job is running. If you click the job, you can see actually what's happening, so you can sit there and watch it. And you notice the first thing it does is, set up Ubuntu, and then it runs the stuff. So actually, if you look, now it's conda. So here's Pixie being installed. It's conda installed. This is the Pixie's output. So that's showing all the Pixie running the tests. And okay, it didn't work. It said, this is why I say this is a bit of a whack-a-mole the first time. It says, oh yeah, PyTest is not installed. So it didn't work. So this job is not there. Well, what does that mean? Well, okay, I need to go to a terminal again here. I need to do Pixie add PyTest, because PyTest wasn't in my environment. I forgot to do that earlier. Great. Right, okay, now let's add Pixie's toml that got updated now to the branch. Added PyTest to Pixie, push. So by the way, these things I'm doing all these pushes and things very fast in the background. I'm used to like doing it graphically like this, so I don't think about it. Normally you'd be typing git commit, git push, but I never remember all the commands. I just do it in this little GUI. And now we go back here to the actions again. You'll see there's another one starts. So this one failed, right? So it just stopped because it didn't work. But now this new one's running, a new change, and it seems. Well, let's hope that one that works. So the post checkout the code's running. Run the test, failed again. Let's see why. Yeah, this is the other problem. I have no tests, right? So here in my version here, I didn't actually write any tests yet because you guys are working on it. So let's add a test. Otherwise, PyTest ran, but it said there were no tests. So let's just go into pcoffee tests. I'll call it test nothing.py, and I'm just going to write a test nothing function def, and I'm going to just say assert true. This is a meaningless test, but it'll at least give something for it to test. Let's maybe make a second one. Test. I don't know. Well, yeah. Let's start with that. But let's show one that works, and then I'll add one that fails later on. So I can add that test directory now. Actually, I had all the tests from. So this will actually add all the tests. That's fine. I forgot that I copied them over from the solution. So now we've added tests, so now we have to go back to look at our actions again. Okay, it's not running yet. One of the issues with this, of course, you're relying on these external services. So here, GitHub's pretty good. The job starts fairly fast, but you're not guaranteed that it's going to run immediately when you push it. So this can slow your workflow down a little bit as you're going because it might take a few minutes for it to start. But in this case, it's going pretty fast. Okay, it ran, and the unit tests, and then I have a green check. So everything I ran worked, and you can see all the things that happened. So it checked out the code, installed Pixie, ran the tests, then it ran some teardown stuff. So post install Pixie, post check out the code, complete job. And you can look at actually the log if you really want to see what happened there. But the main thing is to run the test. That's what we ran, and you can see it ran all these tests that I just copied from the solution. And great, 40 tests pass. If they didn't pass, so you'd get a red symbol here, and the action would say it didn't work, right? So that's actually quite useful because now it means every time I push to my branch, or to any branch actually, because I have it set, any branch that has this particular YAML file in it, GitHub will see that YAML file, automatically run all the things that are in it. And it's super useful to see whether things are working. So that was the most basic test. Let's go back to here. Sorry for a little bit of a hiccup getting it running. Yeah, so here we are. This is where we are now. So we have, I made this a little bit different. I didn't put I broke, in this example here, I broke it into two pieces, say hello and code checks. You could also add something here that runs a second job. So this one would run, like I said, a pixie run rough check. Again, you'll learn about that later, so I won't add that right now. But what are some other things you can do? So if you have more than one job, you can have, like I said, they all run in parallel, but you could have them run sequentially if you want. And let's just try that. So what we need to do first is add a job. Since we only have one job, it's not very interesting, but let's go back to the test.yaml. Let's add a second job. We'll call this code check. Runs on, again, Ubuntu latest. Steps, and then basically it's going to be the same steps. I'm not going to do the printing. We're going to check out the code. Do I need, yeah, I have to install Pixie, but then the next step will be different, so I'm going to just paste that in there. So check out the code, install Pixie, and then I want to make another step. Run, I call it rough. So rough is a utility for doing code checking. By the way, I'm not sure if I added that to list. Should I install add? Yeah, so I need to add that also probably to my Pixie thing, but first, before we run this, before I do that. Okay, but let's do it. And then the run command will be Pixie run rough, and rough check is the thing that runs this. Let's do, before we do it, Pixie install rough, or sorry, Pixie add rough, right? Let's see. Let's just see if it works here. If we do Pixie run rough, see if there's any bad code. So we install. Yep, all checks pass. So okay, the code is well written. This is again the solution I copied from the day one solution. So I hope it's all good. Okay, so that should pass. So now that's a second step. Let's add that to our Git and commit it. check job. And you'll see something has changed over here when we run it again. So when we reload GitHub, yeah, there we go. If you look at this one now, you'll see now there's two jobs running, and they're running at the same time, right? So you're getting unit test and code check. Both of them are spinning up a version of Ubuntu, running a bunch of these things, and then checking if they worked. So they really run independently. And that's. But what I might want to do, so let's wait till it finishes to see if it works. But I didn't break something here. So the code check worked as before. Oh, so that's the new one. Sorry, the code check works. Good. And the unit test we already know works. So it should finish. And it takes a bit longer to run because it has to run PyTest. By the way, if you want to, if these things take a long time, you can cancel the workflow. You can also restart a workflow if you, or just one step of the workflow if you think like that you can go into that one, say rerun all jobs if you think there was a problem, like something was down at the time. Yeah, you can download the logs if you want. You can even look at what actually happened, like while we're doing this. In principle, yeah, it shows how much time it took to run each of these steps. You can get the workflow file if you want to look at it directly here. By the way, I think you can actually edit the workflow file inside GitHub directly if you don't want to use your code editor. Like here, I'm using Emacs, but if you if you prefer to use the GitHub just UI, you can just edit it here. I think it even gives you some help automatically. Okay, but now we have this last one ran. It ran two jobs together. What you can do instead, if you say, okay, I don't really want to run the unit, because let's say the unit tests take a long time, right? Like they only take 3 seconds more in this case, but in principle they take minutes. Is that I don't really want to even run the unit tests if the code checks fail. I want the developer to just check, fix the code first before you run the unit tests. So what you can do is give a dependency here, and that basically you can say.
Excuse me.
Yes.
Just a question. Regarding the reproducibility perspective, is it a good practice to run on the latest version of a distribution?
Probably not the best idea. I mean, it depends well, it depends if you wanted to just, the issue is then, of course, the new version of Ubuntu comes out and suddenly all your tests stop working, right? So you probably should fix the version. Yeah, I would suggest that you give a fixed version and then you manually update the latest one. It depends on what you want to do, though. If you wanted to say, I always want my code working on the latest version of Ubuntu, then you'd put Ubuntu latest, right?
Ubuntu latest is the latest version that GitHub has.
Yeah, it's also not the latest. Yeah.
The latest LTS.
It's even
some time after it was released.
Right. I even showed you here, right? It was 2024.
24.
If you look here, I think it was operating system Ubuntu 2024.04. So it's quite old, right? Yeah. So I mean, but yeah, it's what Ubuntu, what GitHub calls latest, but it will change occasionally, right? So in the future that will get updated.
And you can use your own image.
Yeah, of course. Yeah, you can. Yeah.
On your own runners.
Yeah. GitHub does not allow you to use any image, only the ones that it allows, because it caches them and other things. So, but if you want to use your own image, you have to set up a runner for it. I don't think you can.
It's the virtual machine-based image, but then you can run Docker inside of it. Then you can choose to put any Docker image inside of the.
Yeah,
what you said here is the base virtual machine that is used to execute the build, and they have a choice, I think, just between Ubuntu, Windows, and macOS. But then on Ubuntu, for example, you could use Docker to run an Alma Linux or whatever Docker container to run the test can layer on.
Because maybe there are some distributions that are lighter than the latest Ubuntu that would maybe.
This is the basic image, really the virtual machine that GitHub spins up to run your job. So,
yeah, I mean, you can abuse these in many ways. Like since it's a whole machine, you can install anything you want inside it. I could run a whole, I'm not sure if you can nest VMs, but you might be able to, you could do something really crazy. I mean, I guess at some point, maybe they complain if you use too much CPU or memory or something, but I mean, but generally they allow you to do what you want. Yeah, so you could install a whole Kubernetes inside it, run something, right? Whether or not that's a good idea, I don't know. Generally, though, starting with something like this is fine. If you prefer a different, I have to look at which other ones they allow, but I'll show in a moment. You can certainly run macOS and other ones, but Ubuntu latest is a pretty standard Linux pack one that you can that works. So now, if I want to make, let's say I don't want to run the unit tests unless the code checks pass, I can just add needs here and give it the name the name of the other job, and that creates a dependency. And of course, you can make this much more complex. This can be a graph of many dependencies if you want things. So for instance, imagine later on, I'll show you that you'll have a deploy step, and you won't want the deploy step to run necessarily if the tests fail. You don't want to push a package somewhere if it doesn't work, right? So you have a dependency saying don't do this unless unless the other one has passed. So here I say needs code check, and now so nothing's really changed here. What have I changed? Just that one line. Let's stage that, commit it, add a dependency, push, and let's go back to our actions. So now here's my added dep. This is these by the way, this is just the name of the commit name of each one. And if I click that one, you'll see now it looks different, right? And now it has a little connector line, and that's because it's showing that unit tests will not, even though I define them in a different order, right? I have unit test and code check, but it's going to run code check first and then unit test. So that's how to make them run sequentially if you want, rather than in parallel. In this case, I think I probably would just run them in parallel, but there's cases where you want to stop early because, or don't do one of them because, like a deployment because something isn't working. Anyway, so that's that. Okay, so let's go back to the presentation, and then we'll do a few more advanced things in a moment. So that's what all this needs does. So it takes you from several jobs to jobs with dependencies. The other thing you want to do is probably show off that things are working, and that's something that's really nice is that you get you can create a status badge. You've probably seen these on a lot of repositories where you have this little logo like this saying passing, and all that is you. So this is in the go to this documentation page here, and it tells you use this URL. So in my case, I could create like a markdown image here that says this. So it's my user pcoffee actions workflow test YAML. That's actually mine's now called test YAML, not YAML. So give it the name of your actual workflow file, and then badge SVG, and that's their API for getting a test image. So this image you can put into your README, for instance, and it will be green if it's passing and red if it failed. And it's just nice. It's a way to show off what's happening. I don't know if it's that useful, but it's for yourself also to check that things are working. You could, for instance, if you have a bunch of projects you work on, you could create a little web page locally on your machine that has links to all of your projects, and you'd see green, 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 red, and then you'd know something's broken. So it's really nice for making a little dashboard or something. It's a nice thing. So that's something that you'll see later on. Okay, that was how you just run the tests automatically every time someone pushes to a branch. But I already said that it's sort of useful to know, does it work? Okay, now I know that it works on my laptop. I know that it works on Ubuntu latest, but what if it works? Does it work on Windows? Does it work on Mac OS? Does it work on, I don't know, a different OS distribution, like instead of Ubuntu, another one? Different versions of the OS, maybe. You might want to check that it worked. So people might have an old version of Mac OS. You want to make sure that it still works there. Different CPU architectures, different word sizes. So again, you have to look here. Depends on which system you're using. In GitHub, you're limited to which ones they provide if you don't provide one yourself. But there's a large list of what you can use. I'll show you an example. There's a second thing we want to check maybe, that our code works on different versions of Python. Because as you know, Python, as new versions come out, they add and sometimes even remove some features, even between like point releases, like 3.13, 3.12, 3.11. And you kind of want to keep up with that. Like even though you're using Pixie, and Pixie solves a lot of the problem that it gives you a fixed version of Python, a fixed version of dependencies. But you kind of want to know, like, well, what if I would need a new version of Python, which might be faster? Or what if I need a new version of dependency, which fixes a bug or something? You want to check before you break everything that the new one works. So that's another thing you want to test. So I'll show you how to do both of these things. What you test here, there's a lot, almost everything. There's so many variables here that you can test, right? So you have to kind of just decide for you what's the most important. So if you have a user base, if your code is just for yourself and you're going to run it always on your laptop or on a Linux machine, don't worry about it. But if you want to share it with people who are using Windows or something else, or different OS versions, different Linux versions, then you might want to start testing on other things. So it really depends on your users. And like I said, Pixie solves a lot of the issues, but not everything, right? Pixie will even tell you if there's not a package, for the right architecture, but it's not perfect. So what you can do to do this is actually a little bit like in PyTest, where you parallelized the test, or not parallelized, but you used a parameterized test where you give it a list of parameters and it runs the test n times. You can do the same thing with these CI jobs, and that's called a matrix job. And the only differences are, this is exactly what we had before, is that we can put a variable for the name runs on. For instance, let's say we want to try running on different machines. So we have a variable called OS, and we put matrix.os, and we put a section in our job called strategy. And strategy needs to have at least a section called matrix, and that defines think of it as a n-dimensional grid, and you define the fixed grid points in each dimension. So here I have one dimension, OS, and I want to do 3 elements of that dimension, OS, so Ubuntu, Mac OS, and Windows. And then what will happen is it'll fill in this variable, it'll run this test 3 times and fill in this variable for each one different, as if you change that variable each time, right? So if I do exactly the same one I did before, so I didn't change much, I just added the strategy and I changed this to a variable rather than saying Ubuntu latest. And I now say I want to run these 3, you'll see suddenly you'll get 3 jobs as you had before. So unit tests Ubuntu latest, unit test Mac OS latest, unit test Windows latest. And you'll see one fail if you did something where that's not compatible with that one. So that's really nice. You didn't have to do much. Exact same test you had before, same code runs, but you now are running over a list of options. It's a little bit harder when you want to go to different Python versions because of how Pixie works. But so if you weren't using Pixie, you can imagine in your setup to your job here, instead of just doing checkout, you have a step before this. It would say install Python. You install a version of Python. That's different. But since we're using Pixie to install everything, Pixie installs Python. So what you have to do is go into your Pixie toml and add a feature for different versions of Python. So you can name this however you want, but so here I created 2 features, one called Py through N3 and Py through N2. And the default environment uses, I guess, Py through N4. That's the latest. But I want to test on these 2. And the only difference, the dependencies of that, is that I fixed the Python version in that. So I don't know how much you went over Pixie features. Have you talked about that yet? Okay, so you know that this is just changing one variable, but you still get all the dependencies from the base environment, right? So then I define an environment that uses these fixtures. So I can call it whatever I want. Let's call it env Py through N3, env Py through N2. It doesn't have to be the same name as these. And then you say which features that environment has. You don't need to say default because the default is always implicit there. So this is the same as saying Py through N3, comma default. But so it looks a bit redundant, but this is just telling you I have 2 features, and now I'm creating 2 environments that use exactly one of those features. You could mix and match them if you wanted. And then if you wanted to run locally to test that, you could say, Pixie run in this environment env Py through N3 PyTest, and it would install PyTest and run it there. So that works totally locally. This has nothing to do with GitHub or anything. You can try this. This is, by the way, one of the things you'll have to do in the example. And then it's really simple to also check that. You can make a 2-dimensional matrix. Like I said, the matrix can be n-dimensional. So all I did is added a second dimension. So I have OS as before, and another one I just called environment. Again, these names don't matter. You can call them whatever you want, but here I'm calling environment, and I have these 2 environments. Probably I should add a default one here too, right? To use, so maybe you want 3 there. Because here it'll only run in those featured ones and not the latest one.
You don't have to specify any placeholder as you make with matrix and OS?
Yeah, exactly. So you see now, but the placeholder goes in a different place now.
Sorry,
so here,
I didn't see.
Yeah, exactly. So here now, that's the difference. So now I have this new placeholder environment, but I have to put it somewhere else. So I have in the Pixie install setup, there's actually this is by the way, I got this directly from the Pixie documentation, tells you how to do this. So there's a nice example there. I actually don't know why you need to put this environments here. I think that's just that if you don't put, I think it's optional, but here in this install step, it will install all those environments, I guess. But I think if you were to just do Pixie run that, it would install it. So I don't know. I think this just separates installation from running, but it's not required. I think if you just put this, it would work fine because Pixie knows how to install an environment. It is on the, if the environment doesn't exist, it installs it automatically. But so all I'm doing is basically changing this. I'm putting Pixie run -e, matrix environment, PyTest. And now I have, you'll look, many tests that run. So it's doing a grid of tests. Basically it does the outer product of these 2, right? So you get every combination. Well, not exactly. It's more of the unique combinations of those. So you should get 1, 2, 3, 4, 5, 6, yeah, tests. So you have macOS with Pi through 12, macOS with Pi through 13, Ubuntu with Pi through 12, Ubuntu with Pi through 13, Windows with the FH. So this can get quite big quickly, right? So you can have more dimensions and more of these, you end up running really a lot of tests. But again, GitHub gives us all your runners for free, so it's not, I mean, it's probably wasting some environmental, it's not great for the environment to run thousands of them, but but these tests are not taking a lot of power. So this is the final version that you could create that has the test matrix, and you have, I have my code checks, I have my unit tests, what I showed before, and this is done as a matrix. Oh, by the way, I didn't mention this fail fast. You can put this as either true or false. If it's true, then anytime one of the matrix jobs fails, it just stops all the other jobs, which often can be what you want to do because you want to, that usually means there's a bug that probably will affect all of them. If you don't do that, it'll keep running all of them, and you would see independently whether they work. I think probably true is probably the best. I put false here for some reason. I don't know why. I think because I wanted to check that they were still running each time. But so here also added the default environment, which I forgot in the previous example there. But here you're doing now, 3 in each dimension. So you have 9 different tests that you're going to run. Then that's it. So that's the full example. So now let's talk a little bit about how much time do we have left. This is going to what, 3 until 4, right? So we have so there's not much more here. I think we're going to get finished a little early. So continuous delivery is actually not much different than this. And the idea of continuous delivery is you are not automating testing, but in integration, but you're automating releasing or producing something, an artifact. So in this case, everything was, before continuous integration, everything was internal. It was just at the end, your result is just yes or no, a green or red light, right? But now you want to say, well, okay, I want to produce something and actually make an artifact that I can upload. An artifact, it could be an image, it could be the package, it could be the documentation. And so the idea is usually continuous delivery is something you do often on release, not on push. Although I'll show you there's some blurry lines there, what you want to do. And you can do things like create packages and upload them, whatever, or create other things. You can also create other artifacts. So for instance, like I said, documentation is one that's really common. So you would probably have, maybe, I'm not sure if it's part of CI or CD, but you would build the documentation and then upload it to GitHub pages, something like that. You could also even run your analysis here. And that's actually what the demo or the challenge you're going to get after this. I would only recommend doing this for simple analyses. So like this pcoffee example runs in like 0.1 seconds. So it's not really abusing GitHub to use it to do the analysis. You shouldn't be using GitHub Actions to parallelize your giant petabyte analysis of scientific data. That's kind of against their policy probably. But for generating an image and very quick, it's super fine. Like I said, I even use this when I do LaTeX documents. I have it generate the PDF as an artifact and put it somewhere. So that way I get, when I make a new pull request, I can see the PDF immediately. I can even run PDF diff and have a diff to the main and get so it's totally automatic, right? And this is useful because one, it allows you to, if you use it for packaging, it makes your code super easy to share. Every time you create a release, automatically it's uploaded to somewhere and someone can just type, pixie run or pixie add or pip install or whatever, and they get it. It also allows you to keep documentation up to date. So if you use this for documentation, it's super nice because every time you add to the documentation, it just gets updated on the website. There's some complexities to that where it's a little bit harder. You can do it, but keep like different versions of the documentation and have a version switcher. I won't go into that level of detail here, but it's possible. And again, it's just to reduce human burden because making a release of your software, there's like many steps you want to do there. You want to advertise it, you want to upload it somewhere. You can just automate it all. You don't have to do anything special. The hard work is though setting it up. But how do you do it? It's exactly the same as the CI. It's nothing different. It's just another workflow you create. So, generally it's good practice to make a different workflow for like tasks like that are semantically different, like that if you're deploying something, you make a workflow called deploy. If you're testing, it's called test. If it's that way, each one, and also because each workflow only has one triggers on, you want to group them into files such that they're grouped by trigger. So, so the other triggers you might have not just release, but let's say merge. So let's say I have a pull request. Somebody's opened a pull request. That one on commit, it runs all the tests every time. But then you want to say, well, once we like it and we merge it to main, you want to run something else. Like that's where maybe you want to upload the new documentation because you didn't want to upload that every time they commit. But when we've merged it to main, then we upload it.
Normally, you would like to perform all the tests and to be sure that the test was correct before.
Exactly, yeah. Well, that's one thing you want. Also, that'll something I'll talk about next. But yeah, you would never want to merge before the tests pass either, right? So you want to block that. But I'll give a quick example here. Then you're going to actually try doing this yourself. But you can run your pcoffee analysis, which we have now, which generates, I think, generates a PNG file or something, right? And then you can upload that artifact somewhere, and I'll show you how that works. So let's try it here. So let's make another workflow. This is probably going to go horribly wrong as well, but let's see. Let's make the workflow called analysis.yaml. Okay, and so again, we need a name. Do analysis. Right. I'm going to open this one so I remember the syntax because I never remember it. Okay, on. I have to say, again, let's just do it on push for now. You probably wouldn't want to do this on push, but let's do it because we want to see it each time. And then we're going to have jobs. So I think there's not much we need other than make plot, or so let's call it make plot. And again, we need to check out our codes. I'm going to install Pixie. We're not going to run the test though. So those first two steps are almost always the same in these. Let me get this. I didn't put steps. Why I didn't put the word steps in yet. That needs to be tapped in. YAML can be a bit. Okay, there we are. So we have make plot. The steps of that. We need to tell what it runs on. Let's do again. Latest is fine, I think. Probably we don't. Well, actually, this is a good question. Can you refer to jobs in other workflows here? You can. I still remember what the syntax is. Well, let's not do that yet. But yeah, you would probably not want to run this unless the unit tests work, right? No point in making a plot if it fails. So that you can have a needs. I have to remember what the syntax is to refer to a different workflow. But let's first do it without that, and then we can add that afterwards. Okay, everything looks fine there, and then we need to do something where we actually run the analysis, right? So what is the, let's see, how did I do it in my example? By the way, all these will be in the uploaded example for tomorrow. But I think we can just run Pixie. Oh yeah, right, okay. So we're gonna run two commands, right? So it's gonna be Pixie run pcoffee analyze dash data file, and it's what coffee productivity. It's a bit low. Oh yeah, maybe I should do this in a. Let's do this in a terminal first to see that it works before we upload it wrong. So in my directory here, I can do Pixie run pcoffee analyze. Maybe help because I don't remember exactly what the options are. Yeah, good. So pcoffee analyze dash I'll call it -d data file, and then that's an analysis slash. Actually, let's cd first to the analysis directory, right? We're in the workflows directory, in the right place. So there's an analysis directory, and that's where your CSV files and your fitted, and eventually your fitted model file will go. So our first step, actually, before we do anything, is to run. And actually, I'm going to use. So I don't know if this is another trick of YAML. If you put a vertical bar, a pipe, then everything after that will become like one string that you can type on multiple lines without having to put backslashes and things. So we're going to run a little script here. Let's just put it all into one script. So we're going to do cd to analysis. Okay, that's the first step. Why is it not syntax highlighting that correctly? Oh, yeah, so we tabbed in, I think. Okay, so then we're in CD analysis, and we're going to run Pixie run pcoffee analyze -d, and then we're going to give it coffee productivity. Actually, I'm going to do, so I'm going to Pixie shell so I can shell tab complete here. This is driving me crazy. Okay, so I can do p coffee analyze d, and then it's our coffee productivity CSV. What else do we need to run it? We need output fitted models. So output is something called fitted models.toml. I think that's it, right? Let's see. Oh, and let's maybe put the show rankings, because that's nice to see inside the output. So let's just see this works. I'll make sure that I have things installed correctly. Okay, yeah. So that ran RP coffee and it gave the rankings. So that's a good command line. So I'm just gonna, sorry, this is a bit hard to read on the screen, right? So let me change to a dark color. So let's just copy that. And then I'm going to put that into here. So there's my, oh, but by the way, I have to do Pixie run that because actually, I think I probably have to put that in quotes, right? I'm not sure. It doesn't matter. Then that didn't create the image though, right? We have to run Pixie, what's the other step now? I've never looked at this. Plot, right? So we want to do Pixie, well, let's do it here first again. So p coffee plot, help. So that was, you need the data file, the model file, and the output, okay? So let's do -d again, coffee productivity.csv, and then we need -model, and we'll use the one we would have created in the previous step, so fitted models.toml. Then we need what the output, let's call it analysis.png. Look good, yep. Let's see if that works locally first before we put it into the CI. It's the first time I've run it in a while, so it probably has to initialize some fonts or something. Okay, there it's done. Let's see what we get. So now we have this analysis.png. Okay, it looks okay. Let's check that it's there. So it looks okay. Good. It created what we wanted. Okay. So now we're in our, oops, go back to the right one, to the analysis.yaml. Yeah, this one. So let's use that command. Okay, so that's what we want to do. pcoffee plot that, copy that, Pixie run, and then I'm going to put that in there. Okay, so that looks fine. That should create a file. It should do a bunch of things. It should create analysis.png. Maybe we don't care about fitted models.toml. We can see, but that should run everything. But again, this is more of like a test right now. This is not actually doing anything. So what we want to do is do something with the output. So then we can do another step, and there we're going to use let's say upload results, we'll call it. And there we're going to use is a special one called actions upload artifact, and that's v6. That one, it needs some options. So I say with, and then it's going to need name, and I'll call it results or something like that. And then the path can be multiple lines. Let's also do this like this. We'll put, and this is, by the way, the path should be from your Git repo directory. Let's just do it before I make it too fancy. So you need to put analysis slash, so here we cd'd into analysis and ran it, but we need to put the full path from the beginning of the repo. So analysis slash, what do we call it? Analysis.png. And that's it, right? So that's fine. And everything looks okay, right? So let's try it. So now I have to add this to this analysis YAML to my commit it. It's a new file. And I can push it to my branch. And I go back to my actions here and see what's happening. Oh, and by the way, you'll notice suddenly there's two jobs running, or two workflows running. That's why there's two of these here, because actually I have two files now. So every time I push, there's gonna be two workflows that run. This one is a simple test workflow, that's what I named it. This one's called do analysis. So let's look at the do analysis one. And you can see it's just running the make plot job. And look, it worked. So let's just check that it worked. So it ran the analysis, upload results. So by the way, where did they go? So this upload results, or this upload artifacts action. So GitHub provides you with some storage space. It's limited to a fairly small size, but it gives you some temporary storage space. I think it keeps things for, I don't remember, there's a policy of how long those things get stored. But that artifact will go to that storage on GitHub. So if you had, let's say, a server somewhere of your own, you could then maybe use SCP or whatever here or something, to transfer it to somewhere that you own and have a nice place to store it. But this is just to show that GitHub provides you a place. It's not the most friendly way to do it because GitHub's artifact storage is not the nicest, friendliest thing. But okay, so let's see what happens. So where did it go? Let me just go back to my presentation. So basically what happened is this upload artifact blog uploaded it to this free but not long-term artifact storage. And you'll actually see it in the workflow status view. So let's actually see if that happened. So if I go to the, I always have to figure out where the status view actually is. Back here when you want to look at the, here. And so here's, in this view, you'll see artifacts down here. Now you see there's results. There's like a digest and other things, but you can, a download link here, and you can say download results. And let's see what happens. And unfortunately what it does is it downloads always as a zip file. So this is a bit of a pain. Again, this is one of the annoying things about GitHub artifacts. In principle, if you had lots of different artifacts in there, you'd get one zip file with all the artifacts, so that's sort of nice. But when there's one file, it's sort of a pain. You have to unzip it, and then you can open up the analysis artifact, and there it is. So there's the thing that was produced automatically on GitHub. And that's nice because that lets you then check for every pull request or whatever, you can check that things look okay, right? So you did some analysis and you got an output. Again, that'll get deleted after a few months or something like that, but it's useful when you're debugging things are running. Okay, so that was, I don't have too many things open here. Back to no, here. So the other way that I do actually often is not produce a PNG file. What I would do actually is, I guess you've all used Jupyter Notebooks so far. Have you yeah, not in the school yet, but you will that be shown any? Because there's, okay, because there's an example notebook I saw later on in the solution, but I wasn't sure if it was. Anyway, if you haven't, I like to use the Jupyter Notebook because then you can put all the analysis and things you want to do and have it make plots, and then you just in the CI you can have it run the Jupyter in a mode where it doesn't open up a server. It just generates the output notebook, or you can generate a PDF file from it, and that's super useful because then you have a nice kind of analysis results with all the steps in there. Anyway, that's one thing you can do. So a bit more time, so I can go to a couple advanced topics. I'm not going to go too deep here, but one of the things this was mentioned earlier is like, how do you certainly wouldn't want to allow people or yourself to merge. If you want to keep the main branch always working, you want to disallow people from actually pushing to the main or merging a branch to the main thing if the tests don't pass. And that's another thing you can set up. And this is something you can try setting up on this is another part of your task later on. There's different ways of working. So here what I'm showing is what's called the GitHub flow model of software development. I like this one because it's really simple. Again, that's where you keep main is always the branch that works. There's other models where you have a development branch and a release branch and other things. It gets complicated, but I think this is quite nice. So main, you should keep main always working. That means that every time you want to change the code, and you're kind of already doing this in the school, you create a branch. So let's say I want to make a bug fix, you call it bug fix, something like that, and I start committing things. And eventually I want to merge it. Same thing for a feature. I have a feature, I start committing it. And the nice thing is, these unit tests run every time I push, right, a change, and you get status like failed. Okay, I fixed the bug, and it works. And what you want to do is forbid this part, the merge, from happening if it's not green already. And GitHub allows you to do that, and same with GitLab and all these others. And that's called, well, it's called branch protections and branch rules. And so one thing I think if you create created your fork and you go into the GitHub settings, you'll probably see this little pop-up already saying your main branch isn't protected. So it's already saying you kind of should follow our GitHub recommended way of this GitHub flow model and that protect the main branch. What that means is, protecting the main branch means is you are not allowed to push to the main branch. So if you check out the code, you're in main, you make a change and say git push, it'll fail and say you're not allowed to push to main. And that's very good. I think you should always do that. Don't let yourself commit to main because that encourages bad habits, right? It encourages you to constantly push things and break the code all the time. So it means that'll first tell you, okay, I have to make a branch. So even if you forgot to make the branch, you'll have to then create a branch, type git branch, whatever, and then you can push it and it'll push to a branch, not to the main. So that means that main can only have changes by pull requests and someone accepting the pull request, which is you, of course, or whatever, and saying merge. So main can only be merged to, you cannot be pushed to. And that'll automatically happen if you click protect this branch, but I'll show you in a second how you can set that up otherwise. So you forbid any pushes to main. Code changes require branches and pull requests. And pull requests, then this is the third part you have to enforce, is that pull requests you can only push merge if the CI test pass. So if you had a red light, merge button won't even be there, or it'll be red and won't let you click it. And that's why you see here this green merge pull request, that if one of these was red, this would not be highlighted and you can't click it.
Silly test that assert égale true. So
yeah, here I've cheated, of course, because my tests are too simple. But of course, that's the point: is assuming you have good tests, right? Here I don't have good tests, but well, no, actually, I added all the tests from Vincent, so here actually now I do have good ones. But yeah, that's the thing is you always have to trust. There's always a setup that you assume your tests are good, but that's actually kind of interesting. One thing I found with this model, especially working with other people, this takes the blame off people, which I really like. So often, if you're working with other people and somebody pushes it, you broke the code. They can't break the code. You cannot break the code because it has to pass. And if they broke the code, if they push one of these there and it'll of course be green, but let's say the analysis result now is completely wrong, it's actually your fault, probably, or somebody else's fault, because you didn't write a test to test the right thing. And this is really nice. So when working with people, you get really mad at each other if you're all pushing to the same branch because people be breaking things. This makes it so it's completely up to the automated system to ensure that things don't break, and it's never your fault. And if you push it in, then it's just, oh, we forgot to put a test in for that, but you can't accidentally break the code, and that's really nice. So this makes, I have to say, collaboration much, much better, and I highly recommend it if you're working with other people. But even if you're working by yourself, I do this even on projects where I don't have anyone else, because it means I always have a version of the code that works, and I don't break it, and never in a state where I don't have a broken code. It can be annoying because sometimes you have 20 branches open because different people are working on different things, and you have to think about merging and rebasing occasionally and things, but it means that you can never get main into a state where it's not working. And by not working, meaning that tests don't pass. Of course, it can still be wrong, but at least the tests pass. And again, that's why the tests are kind of a guardrail to make sure things come out right. And if you want to make sure that the analysis results are correct, try to think up some tests that ensures that, right? And then you're happy. And if you're worried that someone's going to break your API or how something works, put a test in that enforces that the API is the way it is, and then no one can break it, right? So anyway, you don't have to do this, of course. You can still benefit from the CI with what I was just doing, but this makes your life a lot simpler. So I really highly recommend this. So this is just, I won't go through this in detail. This is how, you can refer to this page to kind of see how to set that up. But basically you have to go into your GitHub repository. You can only do this for a repository you have admin rights to. So Max, do you have
just to the last slide, I even protect the main branch in repositories where I work alone.
Yeah.
Because I really like the context switch between I work locally, I develop the code, I push it, I open a pull request, and then I context switch to my code review half of my brain, right? And then I review my own code, and the CI runs, and I merge into main with the pull request. So even when I'm working alone, I use this pull request approach and not just pushing to main. I think that works very, very well.
Yeah, I fully agree. Yeah, that's again, it also prevents you from ever having a state where someone says, "Oh, quickly run at your code," and it's broken. It's never broken, right? You might not have the new feature or the bug fix in yet, but it always runs at least, right? So anyway, to do it, you have to go into the GitHub settings on the left. So you click this. Well, I'll show this in a second. And in principle, you click rule sets. I have to say, it's very confusing the way it's. That's why I tried to show step by step here. I find it incredibly confusing every time I look at it because there's so many options. But most of the time, it's all you need is a few of these options. So you want to first add. It says all these other stuff, but one of the things is target branches. You want to add target default. By the way, you can also put main there, but default is main. It's also confusing, but if you click add target, the default branch is main. I think if you clicked that helpful button that it showed here, I think that's what it'll set up automatically there. And then all you have to do is the branch rules. There's lots of other things you can collect here, but you need at least, well, I think restrict deletions was turned on automatically. I put on require a pull request before merging. I think that's not also not required, but I think that's a good idea, right? The other thing here, this is something that I didn't talk about yet, but again, if you're working with a bunch of people, this is another thing that stopped fights by putting required approvals. And this only works if you have a team. This doesn't really work if you're by yourself or with even two people. But here you can say, I require one or two, better two reviews before a thing. So it's not just the test pass, but two people have to review the changes before you merge it, or one, or whatever you set here. And again, that spreads burden out, it spreads blame out too. So that the person writing it, the pull request says, okay, I think I have everything right, but then two people have to say, okay, I agree with it, or suggest changes to them and help them make the code better. They can say, okay, the test passed, but the code is terrible and it's very inefficient, please. Oh, you shouldn't say the code is terrible, you should say there are efficiency issues, and you should fix it. But you have a discussion, and then only when two or whatever people agree, you can merge, you're allowed to merge. So that's the third restriction. You have the test must pass, and second restriction, you have the test must pass, and that at least n people agree that it's okay. And that cannot, the n here cannot be the person who developed the code. It automatically excludes them. So that's why I say it only works if you're have a sufficient sized team, because that means you have to wait for at least two people to read and review each pull request, which can be a pain. But on big code projects, this is super nice. And this prevents, again, people from fighting, because it's never one person's fault. It's now three people's fault if something's bad, right? It spreads out the blame a bit.
Just a comment, because you said that it is the second step, but you still have to perform your test on your local machine. So this is
not really. I mean, you should, yes, but people forget to. So even if they forgot to, all the tests now run, right? You have the unit tests running automatically in the CI and everything, right? So yeah, it forces the unit test to be run. So if you forget to do it on your machine, it's done.
And after teaching at schools like this for many years, I don't trust that people run the tests locally because of the weird setups I've seen on all of these machines. This is a fresh virtual environment with a well-defined software environment, and then it runs the test there, and if they pass, it's fine. If there could be flukes on your machine where you use some weird, I mean, with Pixie probably it takes care of this,
harder,
but the horrible setups we've seen that either make tests fail for no reason or make tests pass when they should have failed, it's trust only the fresh setup, the well-defined infrastructure.
Yeah. And then, the third part you have to set here is, go ahead.
Yes. And for example, I have a friend say that you don't have to push your code to know if it's good or not. You have to push a good code. So
yes, you should. Yeah.
Even if you don't do all the checks in your own machine, you can do the lint, push a good quality code. It's
the more checks you do locally,
yes,
the best. But of course, people forget to do that. That's why. And there's other ways. There's pre-commit hooks, which I don't think we talk about here, but that's another way to enforce before you push that certain checks run, like linting. But again, everything adds annoyance to it. This is like a last resort. No matter what, this is going to run, and it's going to be run in an independent environment on a new machine, as if a new machine was just installed and the code was installed and it ran. So you can't miss something here, right?
You can also stage these different tests, right? Now everything runs in parallel because we haven't defined any dependencies or rules. But in our bigger projects, we run cheap and fast tests first, and only if they pass, we go to the more extensive test suite. So these linting tools, they are very cheap to run, they are very fast. So we run this first. If they pass, then we start into the full unit testing suite, and only later we run the full integration tests. All of the cheap and fast tests have said this is fine, then we do the more expensive one. And like this, we save a couple of resources, of course.
Just to show you, this is a package that both Max and I work on, so it's interesting. They find see, let's find a very contentious one with lots of lots of comments. So here's a pull request where it looks like tests are not passing. There's been lots of discussions, right? Somebody's been working on it. You can look at the checks though, and you'll see for that pull request we have one that does a code analysis, and it says okay, the code is fine. Even here it complains that if it hasn't written a changelog entry to explain the documentation, so it even checks the documentation is properly filled in, and said, yeah, we didn't find any change request for this, so you need to do it. So back to checks, sorry. And then the CI, this is the thing we just said, has lots of tests that run, and you can look. Maybe let's look at one of these. We run a very different. How do you go back to the view? Yeah, so to go up to actions. It's a bit annoying to get how to get to the view of the. So okay, let's look at this, but I'll show the. No, that's just the changelog. I have to choose a job that actually has something interesting in it.
Check CI on the left side, then you only get.
Oh yeah, right. That's what I want. Yeah, exactly. That's what I want to filter by that. So here's one. Okay. So you can see here there was 2 jobs, linting, and linting. If linting failed, it wouldn't have run the matrix. Actually, it's very similar to the one I showed. So this then shows a bunch of test jobs, and no artifacts are produced here, so it's good. So and then it builds the docs simultaneously. Yeah, so you can make this as fancy as you like. I'm trying to think of a better. We have other examples or other things we worked on where it's really a chain of like 10 things like deployment and everything else. So you can get very fancy if you want, but I mean most of the time it's not necessary to go to that level of complexity. Go back to my pea coffee. So anyway, to set this up, we're going to go back to here again. The last thing you have to do, which is also confusing, is click this require status checks to pass. So that's the thing that says don't allow merges without status checks. And then you actually have to list which status checks you want to be required. So that means that you don't have to require all of them. Like you can imagine, say, I'm okay merging if the documentation doesn't build, but I do want the test to pass. So you can select which one. So you can click add checks, and you have to know the names of all your checks. You can search for them here and put all the ones that you want that absolutely have to pass. And if you have, like I said, we often have workflows like a job that tests on the latest version of all the dependencies. That's another one that's kind of nice to do. So it basically does a pixie. I don't know what the command is, but the thing that basically updates to the latest, gets rid of all that, maybe removes all of the restrictions on the dependencies, then does a pixie install on a new environment with no restrictions. That you wouldn't say I require that to work because maybe that's something I want to fix later. I want to be alerted that it doesn't work on the new dependencies, but I don't want that to break. It doesn't break the code because I'm in a pixie environment that's locked. So that one I wouldn't list here, right? But so it'll still show in the pull request, but it won't. It won't be mad when it doesn't work, right? The confusing thing that where I ran into this issue here earlier, trying to show you this, is that I think in this pull request, and now it's here, now it's working. Yeah, so these things now show up. So those I added here in the pull request, and I made them required, right? So by setting them in there, these are now required pull requests. Why are these not completed? I don't know. There, just see. Oh, this is my old. This is my old branch. It's not the new one I just created. But this is when I was testing stuff earlier. So they'll show up into here. I opened the branch in the wrong repo, so it doesn't show up in this one. That's another issue. So if you open the pull request in a repo where you don't have access to run tests, it won't. In forks like this, it won't quite work, right? But it need to be set up in the repo where so in the base school repo, none of the stuff was enabled for allowing me to run tests. That's why my push earlier didn't work. And the first time I tested this, I did it properly and actually opened the pull request in my repo and not in the upper level one. And anyway, then you'd see the things here. And look, you can see here, these haven't worked correctly. And the merge request is blank. I can't merge it because it didn't work, right? And so if I had a pull request that did work, I don't have one that actually passes here, because these are all the ones that I can't run. Anyway, but it would be turned green. Probably if you look at one of the main repositories, we have a few pull requests open that are ready, that work. And you can always see all the workflows are running by going to the Actions tab, so independent of which pull request, because I have no pull request for this one that I just opened here. I didn't create it, but it would show you there. And so all you have to do anyway to set this up, again, is you go to the settings of your repository up here, and then follow what I just showed before. You would create a rule set, and I call this one enforce workflow. You can call it whatever you want, and then you can see it targets the main branch and adds these options. There's other things you can push too. I set block force pushes because I also to main, not to that doesn't affect anything other than main, but that's important because you never want to rewrite the history of main. That's actually bad. It's learned from experience that will break that'll break all of your other people's developers will get very mad at you if you do that. So that's good to keep on. But mainly it's this one, requires status checks, and then if you look inside it, I required that these in particular, these ones work. Notice I put just a few of them, but you could add more of I ran 9 tests, and I only required the 3 of them that worked here. So you have to decide what's important. There's other things you can enable here, like code quality results. I'm not going to talk about here. That's another service that you can have an external service that does code quality, rather than just running a test that runs like I did rough or something like that. And these are actually a bit nicer if you use one of these fancier code quality services like Sonar or what's it called? Coverage, or there's like Coverage.io and a few others that show you not just code coverage, test coverage, and also quality, whether you have bugs, poorly written code or too complex code, and how it changes over time. But that's a bit more advanced.
I think before we switch to our CTO's connective, we use CodeCov for
CodeCov is the other one, yeah.
CodeSC for the static analysis.
Yeah. So there's plugins you can use these other services that are not really CI. They're like CI, but they're another service that runs. Okay, then that I think is the end, which is good timing. Things that you'll hear next week though is how to build packages, and then you can of course add to your CI here to build the package automatically. Same with the documentation. I highly recommend that. And then the activity for today is just to try implementing some of this stuff. So what I think basically just follow what I did before to run at least a test workflow that checks code quality. Like it can just be what I did rough. If you don't know what that means, just run rough check. It runs your unit test. So at least to run the unit tests. Maybe generate a test coverage report too. I didn't put that in mind. So it just means modifying what I had there, add the options that Max showed earlier to generate the test coverage. You can even generate the HTML file if you wanted and upload that as an artifact if you want to be fancy. And maybe, okay, I said here ensure documentation can build, but I didn't realize that's actually next week that you learn how to do that, so don't worry about that part. And then if you have some time, maybe add a status badge to your README to show the status of your main branch or something like that. And that's, by the way, status badge is per branch, but generally the only one you want is main to show that main is working. You wouldn't, unless you have lots of long-lived branches. You don't need to use a matrix in your but eventually you'd want to run a test matrix on several environments. If you have time, try that. Again, you can look at what I did, but maybe modify it to do differently. And this is a very advanced thing, is add a test that updates all of your dependencies to the latest version and runs the unit tests. I forgot to finish the sentence. It should be marked as not required. That's one you don't want to require because again, it's not needed. But there you probably have to modify your PXE toml to add a environment where there's no restrictions on the dependencies. And if you have time, also implement a delivery workflow. So do basically what I did, but maybe produce the plot and maybe also expose the toml, the results file with the model fit as an artifact. So it's basically just cut and paste what I did before, but which is all in the presentation. But yeah, so I think this is not too hard to do, but it's kind of fun. The hard part, like I said, is even what I did there, getting it set up on GitHub first. But there's nothing really to change, to enable. There's nothing to enable to get workflows to run. You just have to push a workflow to a branch, and then it'll immediately run, right? If it says on push. And once it's in main, the main will start having, once you've merged that branch into main will start having results. By default, main doesn't have the workflow file in it, so it won't run it. It only runs in branches that have a workflow file in them. So that's the complexity, but it's just playing with GitHub. So any questions or?
Just a remark. I plan to show what work is next week, so maybe.
Yeah, maybe you don't have to do that, but yeah, don't skip that if you don't. Yeah.
Try to.
Anyway, right now it gives you no answer. Anyway, it gives it's fine with all the code apparently. So.
have a question.
Yeah.
I don't know if maybe this is part of packaging, but what about version, bumping the version?
Oh, of
When-
what? Of a dependency or a.
I don't know, you get a new version of your code, but you want to semantic version it. So is this a part of the CD?
Oh, you mean to check that the version number is correct, or automatically generate the version?
Yeah,
number?
just automatically generate.
That it's yes. Yeah, maybe you can answer it better, but.
So what I recommend here is to just use the Git information. And there are plugins for the Python packaging system. For example, for setup tools, if you use that to build the package, there's setup tools SCM. And then you just create a new tag. And the version that it will insert into your package will be based on the last tag. So if you create the tag and you're exactly on the tag, you will use 1.0.0, and that's the version. And then if you have added commits since the last tag, it will do something like 1.0.0.1 dash however many commits you added dash the git hash of the current commit. And that's very useful. And you don't have to remember that you need to increase version numbers. You just, if you are ready to make a new release, you create a new tag and the version is automatically included in the Python package information by this plugin, reading the Git information and including it in the build package data.
I think even if you make a new, I mean, if you go into, we haven't gotten to releasing yet, that's going to be next week, but I think if in GitHub, if you create a release, it creates a tag automatically. So
Yes,
even if you go through so all you do is click, make a release, suddenly you have a tag. As long as you name that tag by your versioning scheme, like semantic versioning, and then you use one of these systems like the.
When you can go into
SCM.
CTA pipe and show our pipe project toml, there
Yeah.
you see how this is
So I
used.
can do it here, make this, make it a bit smaller. Get to, where's my, here. Pi project, right, that's where it is.
Yeah.
That one, right?
So you see in the build system requirements at the top, maybe you can increase the font size a bit. There's setup tools and setup tools SCM, and the SCM is, I think, for source control management. So it's similar to version control management, right? It's it is a plugin to extract information from Git or from CVS, SVN, whatever. I think it supports a couple of options. And then you will find in the project table below an entry that's called dynamic. And the version number we have is dynamic. So this is filled in automatically from the Git information by setup tools SCM. And if you now in the terminal in CTA pipe, you run Python -m setup tools SCM. If you have it.
Yeah, there's a setup tools SCM.
Yeah. If you have it, I mean, probably
should be there, right?
in the CTA dev, it should be there. But
Yeah.
yeah, okay. And you see, we have 0.27.2 is the last tag that Karl has locally checked out, and then we are 244 commits after this tag, and the current commit we are on is this hash.
Like I think even up to, so the last tag was 0.27.1, and I think it automatically makes
Yes, it bumps by one.
Bumps it, right?
And then
So
it's the development version.
It's the two
244
development, yeah,
after
exactly.
that.
So that's so it's really nice. That keeps you from making. I mean, it's a bit of a pain to set up originally, but it's very nice to use. Yeah.
Maybe we didn't touch this already, but how did you define a tag? When you decide this stuff that I've just done, okay, it could be a tag.
Yeah. So there's two ways. There's when you are in GitHub. Where did I put it? In GitHub, if in your thing here, I always forget where is release? Yeah, releases. You click create a new release, and you'll see select a tag. But if you don't select a tag, let's say call it 0.1. I'm just call it that. Create it. Create new tag. Create, and now it's created. And I'll call this v 0.1. And now publish release. And now I've created a release 0.1. And now if I were to look in my if I was to do git pull again to get the tags, actually I have to put git pull dash tags, I think, right? Does it by default now pull? Yeah, let's try it. Let's make a new. So this is in p coffee. Make this a bit bigger.
If you just do git fetch, it should fetch. Yeah, and if you do
Yeah.
git tag, it shows a list of tags.
Yes, now there's D0 and V1.0. So now that tag's there. But the other way you can do it, of course, is do git tag. But that doesn't make a release automatically. So either you git tag first, then go into GitHub and say make a release based on that tag, and you choose which tag, or just do it all at once. It's easier to do it all at once. But git tag, there's 2 types of tags you can create, but that's another issue. But that's, yeah, it's pretty easy to do. And if you do git log, you'll see it'll show the tag now somewhere. Let's see, by default, doesn't it? Or do I have to?
I think you have to do -- decorate.
Yeah, decorate equals full or something like that. Yeah. Here's where's the tag? Where's?
Oh, you didn't pull. You just fetched. So
Oh yeah, right, yeah.
You are also at new CI.
Yeah. Let's go back to main. Git pull. Yeah, now we do. Some fancy thing. Yeah, then you see the tag here is we're at V1.0 right now. Which also I think if you're in like I always suggest using GUI things for.
And we discussed yesterday a bit what is inside of Git and what is additionally provided by the step posting, the forges, and Git tag is really information that is stored in the repository itself. And then GitHub release is basically a nice web page that points to one of these tags, and you can add some additional information like a change log, or it shows the number of merge pull requests since the last tag and the changes. So this always points to a tag.
This could be automatized. Yesterday you showed that you can get the contributors from
Yes.
And
Yeah.
also the main difference, I guess.
Yeah. 2 last questions are things I trying to explain more in detail.
Just a pixie questions. When you do the matrix for all the Python version and the test in all this version with PyTest, I think that in this case you have to create one environment for each
So
Python and test. We have Python environment, a test environment, but we have to multiply that to have a Python plus test.
yeah, this is what I did in the solution, which I'll upload later on. But there's different ways you can organize Pixie. So the way that Vincent and Thomas organize this is that the test environment is your default environment, and then you derive environments from that. I often do it the other way around, where I make the test environment as the deployment environment, and then you have a test environment as a separate. I call it like test default, test 3.1 or whatever. But it doesn't matter, right? They're all just a bunch of. So here they have. Yeah, this is from the solution later on. That you have a prod environment and some test environments and a default environment, which is the default one has the dev features and the, let's say, Python 3.1.3 features, and then you test on 3.1.4 and 3.1.2 in these modified ones that are basically, but there's different ways, like I say, you can choose which way you break your environments up, but there's environments and there's features and there's different things, right? So each environment is just a list of which features to include. And so you can have, what I did in my example in the presentation, I made an environment per feature, but you can do it this way, which is a bit different, where you have environments with multiple features. And yeah, but yeah, you do need to have a different environment for each version of Python, though, because that means you have to install. I mean, that everything depends on Python, so of course you have to have an environment for. Anytime you change a dependency, you have to have a new environment, which is a bit annoying, but it's really. But again, Pixie, I think the advantages of Pixie outweigh the little bit of complexity you need to create an environment for each one, right? Because you still have to create that environment somehow to test different versions of Python. So if you're using Conda or if you're just doing pip, you'd have to, in your CI, you'd have to install a new version of Python and then run pip with that new version of Python. And that's not actually that easy to do, because like Ubuntu, I think you can't just say install Python 3.12. It does whatever the Python is, the official one of Ubuntu is what's installed. You can't change it easily without an external manager like Pixie. Okay, any other questions, or are you ready to try out this stuff? Yeah, we'll walk around and help if there's questions about how to get the stuff to work. But mainly, just create one of these workflow files inside Look at the presentation, cut and paste if you want. Make a workflow file inside your .github/workflows and push it to a branch and see what happens and see if it works and try playing with different options.